Hi guys, today I'm going to show you how to solve decomposition problems, and we're going to do that by solving this problem right here. I am going to show you two ways of solving this problem. So first we're going to use differential equation, and the next step is to use the rate of decay, which is also of course derived using differential equations, but since we already have a derivation of this, we are already using this in a lot of problems in chemistry, and we also derive this in the applications of differential equations, no? So we're just going to use the derived equation in solving this problem. So let us first read our problem, and then we're going to solve this first using differential equations, no? So the tank has a capacity of 15 cubic meters. If its capacity is decreasing by 15% every year, what will be its capacity 5 years from now? Okay, so we have our initial condition here, which is the capacity of the tank, which is 15 cubic meters. And we are told that its capacity is decreasing by 15% every year. So that will be our rate constant. Then what will be its capacity 5 years from now? So this is what we're going to determine. What will be the capacity of our tank 15 years from now? So let us first use differential equation. So we know that our capacity is changing with time. So we have our dc over dt, which is the change in capacity over the change in time. And since it is decreasing over time, so we will have a negative value here. And it is decreasing 15% every year. So it will be 0.15 because it is decreasing 15% every year. Okay, so that's why we have negative 0.15. And what is changing? It is the capacity of the tank. So the capacity of the tank is decreasing by 15% every year. Alright, so we're going to arrange our differential equation here. So we will have dc over c is equal to negative 0.15 dt. And now we're going to integrate both sides. So we'll take the integral of dc over c and take the integral of negative 0.15 dt. Okay? Alright, so the integral of dc over c is ln c. And this is equal to the integral of negative 0.15 dt, which is negative 0.15 t. And of course, di natin dapat kalimutan yung plus c. Alright, so if we have an indefinite integral, of course, we need to find the value of our constant c here. So let us first analyze our initial condition. Okay, so what is our initial condition? So in our initial condition, our time is equal to 0. Right, so at time is equal to 0, our capacity c is equal to 15 cubic meters. So our capacity is equal to 15 cubic meters. So we're going to substitute that here sa ating nakuhang sagot. So we have ln 15, okay, because we have ln c here, which is equal to negative 0.15 times time. Our time is equal to 0 plus c. So therefore, we are now able to determine the value of our constant c. Our c is equal to ln 15, right? So now we're going to check what is the capacity at time is equal to 5 years. So yun ang hinahanap natin. 5 years from now, what will be our capacity? So our time is equal to 5. So we're still going to use the same equation na nakuha natin dito, no? So we have ln c is equal to negative 0.15t plus C. And we know that our C is equal to ln 15. So the only thing that we need to do now is to substitute the value of our T on our equation. So we have ln C is equal to negative 0.15 times T, which is 5, plus ln 15. Okay, so let us get the value in our right hand side of our equation. So we're going to use our calculator. So we have negative 0.15 multiplied to 5, then we're going to add ln 15. Okay, so we have 1.958. So we have ln C is equal to 1.958. Okay, so just to make sure, let us see 1.958. Okay, so in order to get the value of C, okay, we are going to apply our property for natural logarithm. So we have e to the ln C is equal to e to 1.958. Okay, so using our natural logarithm properties, we know that e to the ln C is equal to C. So this is equal to, let us use our calculator. So we're going to raise this, okay, using e. So we have 1.958. So we have 7.085. 7.085 cubic meters. So this will be the capacity of our tank after 5 years. Alright, so now we're going to use the rate of decay equation. Okay, we already derived this in our application of differential equations. And we got this equation. We have x is equal to xo e to the negative kt. Okay, where x is our capacity or concentration at a given time. XO is our capacity or concentration at the initial state. Then K is our rate constant and T is our time. Okay, so we want to know what will be the capacity X at time is equal to 5 years, right? So we don't know what's the value of X, but we know our initial condition. So the capacity at time is equal to 0 is, let me review what's that. At time is equal to 0, our capacity is 15 cubic meters. So our XO is equal to 15. Then E to the negative K. So our K is 0.15. So as you can see, this is already negative because we are using the rate of decay. So this is already a decomposition equation, right? Then multiply to time. So we want to know what is the capacity 5 years later. So we have 5 here. So we have X is equal to 15 e to the negative 0.15 times 5, which is 0.75. Okay, so we're going to use our calculator here. Okay, so let's see. Let me solve this first. We have e to the negative 0.75. Then multiply that to 15. So we have 7.0855 okay, 0.855 cubic meter. So this is our answer using the rate of decay equation. And as you can see, we have the same answer in here. So in here kasi, if you remember, we rounded off here. Kaya naging halos eksakto itong value natin compared with our value here. Okay, so this is how we solve decomposition problems either by using this method, okay, applying the whole differential equation solution, or you can use the rate of decay equation as we have done in here. So if you already know about this equation, it will be easier now in solving problems similar to this one. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.